Good morning, students. In today's class, we're going to see butyric acid fermentation. In yesterday's class, we had seen alcohol fermentation and lactic acid fermentation. In today's class, we're going to see butyric acid fermentation. Butyric acid fermentation is carried out by obligate anaerobic spore-forming bacteria belonging to the genus Clostridium. Here we have taken the example of Clostridium acidobutylicum. I repeat it. Butyric acid fermentation is carried out by obligate anaerobic spore-forming bacteria belonging to the genus Clostridium. And here we are taking the example of Clostridium acidobutylicum to carry on this process. Okay. Now if you see here, glucose is a precursor and we have several end products. Our main aim is formation of butanol, butyric acid and formation of N-butanol. These are the two end products that we require because we are studying butyric acid fermentation. But apart from butyric acid and N-butanol, we also have four other important end products which I have encircled in green color. Acetic acid is one, acetone, isopropanol, ethanol. Okay, so totally we are having 6 end products. Glucose is a precursor which is giving rise to acetic acid, acetone, isopropanol, butyric acid, N-butanol and ethanol. Now these 4 are not required, but they are coming out as byproducts when glucose is being broken down. Okay, we require butyric acid and N-butanol in this pathway. Apart from that, these are the 4 byproducts which are also released: acetic acid, acetone, isopropanol and ethanol. Now we're going to get inside the pathway. So glucose is converted to pyruvic acid by the process known as glycolysis. Okay, so the spelling is wrong here. So by glycolysis, now this pyruvic acid in presence of pyruvate dehydrogenase complex is forming acetyl-CoA. We are aware of this step because we have already learnt it in TCA cycle, right? So now this acetyl-CoA, from here it is something new for us. So this acetyl-CoA is giving rise to acetic acid. Okay, with removal of one CoA molecule, it's giving rise to acetic acid, and again at the same time, because these are all 2 molecules of acetyl-CoA, because pyruvic acid is 2 in number, so acetyl-CoA is also 2 in number, giving rise to acetic acid, and one more acetyl-CoA giving rise to acetaldehyde. Okay, now this acetaldehyde further gives rise to ethanol. Now these are all the byproducts which we are not concerned right now. This acetyl-CoA, it combines with one more molecule of acetyl-CoA and loss of one CoA. This acetyl-CoA combining with one more molecule of acetyl-CoA with loss of one CoA molecule in presence of the enzyme thiolase. thiolase. Acetyl-CoA is combining with one more molecule of acetyl-CoA in presence of the enzyme thiolase to give rise to acetoacetyl-CoA. Okay, this acetoacetyl-CoA once again is giving rise to a byproduct acetoacetic acid, which is converted to acetone and further reduced to isopropanol. So each and every intermediate which is there in this pathway is giving rise to certain byproducts. Okay, now this acetoacetyl-CoA in presence of beta hydroxybutyryl-CoA dehydrogenase. DH stands for dehydrogenase. Whatever I have written in red color is the names of the enzymes. Okay, so here the enzyme was thiolase. Now here beta hydroxybutyryl-CoA dehydrogenase is the enzyme which is reducing acetoacetyl-CoA to beta hydroxybutyryl-CoA. This beta hydroxybutyryl-CoA with removal of one water molecule in presence of the enzyme crotonase is giving rise to crotonyl-CoA. This crotonyl-CoA again in presence of butyryl-CoA dehydrogenase, okay, is giving rise to butyryl-CoA. Crotonyl-CoA in presence of butyryl-CoA dehydrogenase is giving rise to butyryl-CoA. Now this butyryl-CoA at one point is giving rise to butyric acid. With removal of a CoA molecule and addition of water molecule, it is forming butyric acid, right? And this butyryl CoA at the same time under alkaline conditions. So here this N-butanol is formed under alkaline conditions. This butyryl CoA under normal conditions is giving butyric acid, okay? But under alkaline condition, in presence of two enzymes, those are butyryl CoA dehydrogenase and butyryl aldehyde dehydrogenase. These are the two enzymes which is giving rise to butyryl aldehyde and further to N-butanol. Okay, understood? So this butyryl CoA is giving rise to butanol under alkaline conditions in presence of these two enzymes. So in this way, N-butanol is formed and even butyric acid is formed. N-butanol is formed under alkaline conditions. Okay, now in this overall pathway, if we see, from acetic acid 1 ATP is released, and from butyryl CoA one more ATP is released during the process, and from when butyryl CoA is getting reduced to butyraldehyde and N-butanol under alkaline condition, one more ATP is released. So on the whole, in this entire pathway, one molecule of glucose is giving rise to 3 molecules of ATP. Okay, so your butyric acid fermentation is, the energetics of butyric acid fermentation is 3 ATP per molecule of glucose. Is it clear? So this is about butyric acid fermentation. Butyric acid fermentation, you know, in which way butyric acid fermentation also takes place in the living body, in the human body also, especially in the gut where the dietary fiber is broken down, butyric acid is formed. This butyric acid is useful as an energy source for the reactions that take place in the colon, in the body. Okay, I hope it is clear. If you have any doubts, you can ask me. Thank you.